Hello students, I am Dr. Rajesh Sani, working as assistant professor in GMN College Ambala Kent in the Department of Mathematics. So today I am before you all with my second video, and today we will discuss what is asymptote, and in this we will try to understand the concept of asymptote, that is its definition, and what are different kinds of asymptote, and how we can find the asymptote of the given curve. So in this video we will try to grab the idea of the asymptote. Firstly, we shall see the definition of the asymptote. So definition is given as: in analytic geometry, an asymptote of a curve is a line such that the distance between the curve and the line approaches 0 as one or both of the x or y coordinate tends to infinity. So we can call asymptote as a line that touches the given curve only at infinity and moves parallel to itself, and in such a way that the distance between the line and the curve is very small, and then they will never touch, and they will touch only at the infinity. Or we can also say that the line and the curve will move parallel to the each other. Now we will verify this concept of asymptote through an example. Let us take an example of a curve xy is equal to 1, which is a rectangular hyperbola. In this, y can be written as 1 by x, and y approaches to 0 as x approaches to infinity, or x approaches to minus infinity. Also, x can be written as 1 by y, and x is running to 0 as y is running to infinity, or y is running to minus infinity. Also, we see that the curve is symmetric in the opposite quadrant, as when we replace x by minus x, y by minus y, the equation of the curve will remain the same, as this will become something like this one. So x y is equal to 1. Therefore we can say that curve is symmetric in the opposite quadrant. Okay, and the figure of this rectangle hyperbola is given by this one. So here if we see this is the curve, okay, this is the curve, and it is symmetric in the opposite quadrant. This one is the first quadrant and its opposite is third quadrant. Opposite means when x is changed to minus x and y is changed to minus y, equation of the curve is remaining the same. So this is symmetry with respect to first quadrant and third quadrant, which are known as opposite quadrants. So this is the figure of the rectangular hyperbola, and in this hyperbola the curve is approaching near to x, as x is running to infinity. Also the curve is approaching to negative x-axis as x is approaching to minus infinity. So therefore we can say that x-axis is the asymptote to the given curve, and this asymptote is known as horizontal asymptote. This asymptote is known as horizontal asymptote. Now also look, the curve is approaching to y-axis as y is running to infinity, and also curve is approaching to y-axis as y is approaching to minus infinity. So therefore there would be no exaggeration in saying that y-axis is also asymptote to the given curve and is known as vertical asymptote. So this given curve has two asymptotes. One is x-axis, which is given by y is equal to 0, and another one is y-axis, which is given by x is equal to 0. X-axis is known as horizontal asymptotes and y-axis is known as vertical asymptote. So the given curve has two asymptotes. One is the x-axis and another one is y-axis, and in other words these asymptotes are also known as horizontal asymptote and this one is known as vertical asymptote. So asymptote is a line that will touch the curve only at infinity. So in this case this curve will touch the y-axis only at infinity, and here also this curve will touch the x-axis only at infinity. So we will again verify the definition of the asymptote. Now look at this definition. I am going to read out and verify it with the example given. In analytical geometry, an asymptote of a curve is a line such that the distance between the curve, this was the curve, and the line, this was the line, okay, approaches 0, and this is the distance, na? This distance is narrowing. So between the curve and the line approaches 0, this distance is approaching to 0 as one or both of the x coordinate tends to, as x is approaching to infinity, this distance between the curve and the line is approaching to 0. So therefore x-axis and y-axis are the asymptote of the given curve, this one, okay. So we have just understood what is asymptote. Now we have seen that asymptote will meet the given curve at infinity. Therefore from here we can draw an inference that asymptote is of infinite length. So this will help us in inferring an important result, and that result is given by any curve of finite length has no asymptote. Because asymptote is of infinite length, and if curve in itself is of finite length, how can you even imagine of having its asymptote? Forget about asymptote, it will have no asymptote. So having finite length of any given curve guarantees that that curve will have no asymptote. So this property of asymptote, that it will have infinite length, have given us an important result that any curve of the finite length has no asymptote. So for an example, let us take the curve x square plus y square is equal to a square, which is a circle centered at origin and having radius equal to a. Its figure is this one, which is centered at origin and having radius a. Now we see the circumference of this circle is finite and is equal to 2 pi a, okay, which is finite. So this curve has a finite length. So this curve can have no asymptote because its length in itself is finite. So how can you even think of having an asymptote of infinite length of a curve that in itself has a finite length. So this circle has no asymptote. This circle has no asymptote. Now we will study the different kind of asymptote. We have two kinds of asymptote. Number one is parallel asymptote. Number two, oblique asymptote. Parallel asymptote is the asymptote which are parallel to the axis. So these are the asymptote. Parallel asymptote are the asymptote parallel to axis, that is both x-axis and y-axis. So we have two kinds of parallel asymptote. One, the asymptote which is parallel to x-axis, and the other asymptote which is parallel to y-axis. The asymptote parallel to x-axis is called horizontal asymptote, and asymptote parallel to y-axis is called vertical asymptote. In the earlier example studied, we have discussed the asymptote of the curve xy is equal to 1, and it was having two asymptote, x-axis and y-axis. The asymptote which is x-axis is known as horizontal asymptote, and the asymptote which was y-axis is known as vertical asymptote. So the first example taken gives us the idea of parallel asymptote. So here x-axis was the horizontal asymptote and y-axis is the vertical asymptote. So these two were the parallel asymptote. Now next we shall see what is the oblique asymptote. What is the oblique asymptote? Oblique asymptote is the asymptote which is obliquely means having angle between 0 and 90 degree, which is obliquely inclined with the axis. So that asymptote is different from parallel asymptote and are known as oblique asymptote. So this concept is verified through the figure which is given as, in this figure, this one is horizontal asymptote because this is parallel to x-axis, and this one is vertical asymptote because this one is parallel to y-axis, and this one is obliquely inclined at some angle with the axis. This angle is obliquely inclined. So this asymptote is known as oblique asymptote. So these two are parallel asymptotes. This one is obliquely asymptote. So here we see asymptote touches the given curve only at infinite distance. Similarly, in case of vertical asymptote, the asymptote will touch the curve at infinite distance, and also in case of oblique asymptote, the asymptote will touch the curve at infinite distance. So asymptote will move parallel to the curve and will touch it only at infinity. Therefore, the definition of asymptote can easily be remembered by taking it as an analogy to the famous Hindi song, and the lyrics of the famous Hindi song goes something like तू जहाँ जहाँ चलेगा मेरा साया साथ होगा. Saya means shadow. So wherever you will go, my shadow will follow you. So in this case, asymptote is the shadow of the given curve, and the asymptote, the shadow, will move wherever the curve will go and will touch it only at infinity. So we can take asymptote as a shadow, saya of the given curve, and it will move parallel to the curve and will touch it only at infinity. Now we will study how to find out the parallel asymptote of any given curve, and once we are able to find the parallel asymptote, after that we will try to learn the technique to find the oblique asymptote. Firstly, we shall learn to find the parallel asymptote. The question is, find the vertical asymptote of the curve y is equal to 2x by x square minus 4. So in this case, we see y will become infinity if x square minus 4 is equal to 0. This implies that if x will become x plus minus 2, therefore y will approach to infinity as x will approach to plus minus 2. This implies that x is equal to plus minus 2 are the asymptotes of the given curve, because at the asymptote the given curve will become infinity, because we know that the given curve will touch the asymptote only at infinity, and asymptote is x is equal to plus minus 2. When we put x is equal to 2 over here, so y will become infinity. So x is equal to 2 and x is equal to minus 2 both have the symptom of becoming the asymptote. So therefore x is equal to plus minus 2 are the asymptote of the given curve, and these two are the lines parallel to y-axis, hence are vertical asymptote. The figure of the given equation is given by this one. Here this line is x is equal to 2 and this line is x is equal to minus 2, and these asymptotes are asymptote which are parallel to y-axis and hence are called vertical asymptote. Therefore x is equal to plus minus 2 are the vertical asymptotes of the given curve. Next we shall find the asymptote of the curve y is equal to e raised to the power x, that is exponential function. Here we see y approaches to 0 as x is approaching to minus infinity, as x is approaching to minus infinity. Therefore y is equal to 0 is the asymptote to the given curve, that is x-axis is the asymptote to the given curve. Here y approaches to infinity as x approaches to infinity. So this will not solve the purpose because both are approaching to infinity as x is approaching to infinity. While in case of asymptote, if one is approaching to infinity, other shall approach to 0. In this case, x was approaching to infinity and y was approaching to 0. Therefore, y is equal to 0 is the asymptote to the given curve. Because in this case, y has become 0 when x is equal to minus infinity. So length of the asymptote has become infinite and the curve has come closer to x-axis, The figure of the curve is given by this one. Here we see as x is running to minus infinity, so the curve is approaching to x-axis. Y of the curve is becoming 0. Therefore this line, which is the x-axis and this is the y-axis, this one is the minus x and this one is the minus y. Okay, so therefore this line y is equal to 0 is the asymptote to the curve, and this curve is of exponential function y is equal to e raised to the power x. Therefore y is equal to 0 is the asymptote to the given curve, and this asymptote is known as horizontal asymptote. Next, we find the asymptote of the third curve, and question is find asymptote of the curve y is equal to log x. So this can be written as e raised to the power y is equal to x. This implies that x will become 0 as y will approach to minus infinity. Therefore the x is equal to 0 is the asymptote to the given curve, and this asymptote is a vertical asymptote. Here we see that as the y will approach to infinity, x will become 0. So x is equal to 0 is the asymptote to the given curve, and the figure of the given curve is given by this one. Here we see as y is approaching to minus infinity, so this is minus y and this is minus infinity. As y is approaching to minus infinity, x of the curve is becoming 0. So therefore this line, which is the y-axis, is the asymptote to the curve y is equal to log x, and this asymptote is the vertical asymptote. Okay, once again this asymptote is touching the curve only at infinity and it is moving like its shadow. So once again I would recall that famous Hindi song, and the lyrics of the song were something like तू जहाँ जहाँ चलेगा, मेरा साया साथ होगा. So asymptote is a shadow. Once again we have shown that asymptote is a shadow to the curve. Now let us take another question and try to solve it. The another question is, find the asymptotes of the curve y is equal to secant x. It can be written as y is equal to 1 by cos x. Y will become infinity if cos x will become 0. This will become 0 if x will be 2n plus 1 pi by 2, where n is belonging to set of integers, and you know set of integers contains 0, plus minus 1, plus minus 2, and so on. Therefore y will approach to 0 if x will be pi by 2 when n is 0, and when n is minus 1 it is minus plus minus pi by 2. Similarly, putting positive and negative values, plus 3 minus pi by 2, and so on. Therefore x is equal to plus minus pi by 2 plus minus 3 pi by 2 are the vertical asymptotes of the given curve, and the figure of the curve is given by this one. Here we see x is equal to pi by 2, x is equal to minus pi by 2 are the asymptote, because they are touching the curve at infinity only, and this is also touching the curve at infinity only. Similarly 3 pi by 2 and minus 3 pi by 2. So it has infinite number of asymptote. It is the figure of the curve y is equal to secant x. Now we shall take the next question, and next question is, find the asymptotes of y is equal to cosecant x. We know cosecant x can be written as 1 by sin x. Y will become infinity if sin x is equal to 0, and sin x will be 0. This implies that when x will be n pi, where n belongs to set of integers. Okay, and you once again know set of integers is equal to 0, plus minus 1, plus minus 2, and so on. This implies that y will approach to 0 if x is equal to 0, plus minus pi, plus minus 2 pi, and so on. Therefore x is equal to 0, plus minus pi, plus minus 2 pi are the vertical asymptotes of the given curve, and these are infinitely many, and the figure of the given curve is given by, here x is equal to 0 is the asymptote, and x is equal to minus pi, x is equal to pi are the asymptotes. Similarly x is equal to 2 pi and x is equal to minus 2 pi are the asymptote, and these are the vertical ones. So these are the vertical asymptote and are infinite in numbers. Therefore the curve y is equal to cosecant x has infinitely many vertical asymptotes. Now next we take that find the asymptote of y is equal to tan x. We know y is equal to tan x can be written as y is equal to sin x by cos x. Now see, sin x is always between minus 1 and 1. It can never become infinity. So the possibility for this y becoming infinity is only through cos x, which is in the denominator. If cos x will become 0, this will become infinity. Therefore, we can write y is equal to infinity if cos x is equal to 0. This implies that x is equal to 2n plus 1 pi by 2, where n is belonging to set of integers, okay, which is 0 plus minus 1 plus minus 2 and so on. Therefore, y is equal to infinity if x is equal to plus minus 5 by 2 plus minus 3 pi by 2 and so on. This implies that x is equal to plus minus 5 by 2 plus minus 3 pi by 2 are the vertical asymptotes. Now the figure of this y is equal to 10x is given by this one. Here x is equal to pi by 2, x is equal to minus pi by 2 are the asymptotes, x is equal to 3 pi by 2, x is equal to minus 3 by 2 are the asymptote as they are touching the curve at infinity. Okay, so these are the shadows of the curve. So this is the figure of y is equal to 10x. Next, we shall study the general rule to find the asymptote of any given algebraic equation. So what will be the general rule? So we shall study these general rules to find asymptote of any algebraic equation. The working rules are given by these. To find asymptote parallel to x-axis, we equate to 0 the coefficient of highest degree in x in the given curve to 0. Means coefficient of highest degree in x is equated to 0 to find the asymptote parallel to x-axis. And one more thing to be noticed is that if the coefficient of highest degree in x is constant, then the given curve has no asymptote parallel to x-axis. Similarly, we can deal with the asymptote parallel to y-axis. Okay, in that case, we find the coefficient of highest degree in y and equate it to 0. And if that coefficient is constant, then we have no asymptote parallel to y-axis. Similarly, asymptote parallel to y-axis can be determined. Now let us just understand these rules through an example. Find the asymptote of the curve, and the equation of the curve is x square y square minus a square x square plus y square minus a cube x plus y plus a4 is equal to 0. Now this is a curve of degree 4. It is 2 degree in x, 2 degree in y, so total degree is 4. So this is a curve of degree 4. Now highest degree in x is x square and x square. So this equation, firstly we find asymptote parallel to x-axis. The above equation can be written as x square y square minus a square x square minus a square y square minus a cube x minus a cube y plus a4 is equal to 0. This implies that y square minus a square x square minus a square y square a cube x minus a cube y plus a4 is equal to 0. Now highest degree in x is 2 and its coefficient is y square minus a square. So we shall equate the coefficient to 0 to find the asymptote parallel to x-axis. So this implies that y square minus a square is equal to 0 implies y square is equal to a square. This implies that y is equal to plus minus a are the asymptotes parallel to x-axis. Similarly, to find asymptote parallel to y-axis, now equation 1 can be written as x square y square minus a square x square minus a square y square minus a cube x minus a cube y plus a4 is equal to 0. Now we have interest to find asymptote parallel to y-axis. Therefore, we have to see the highest degree in y. This is the highest degree in y square, and this is also the highest degree in y, that is y square. So club these two. So these two are clubbed as x square minus a square. This is y square minus a square x square minus a cube x minus a cube y plus a4 is equal to 0. Now y square is the highest degree in y, and its coefficient is x square minus is equal to 0. So we put x square, its coefficient na x square minus a square is equal to 0 to find asymptote parallel to y-axis. This implies that x is equal to plus minus a are the asymptote parallel to y-axis. Therefore, we have seen the given curve 1 has 4 asymptotes. These are given by y is equal to plus minus a and x is equal to plus minus a. 2 are the horizontal asymptotes and 2 are the vertical asymptote. These are known as horizontal asymptote and these are known as vertical asymptote. Therefore, the given curve in equation 1 was of degree 4, and we have already determined 4 asymptotes. So we also know a very important result: the number of asymptote cannot exceed the degree of the given curve. Degree of the given curve is 4. So we are already find the 4 asymptotes. So therefore, the given curve will have no oblique asymptote. This is direct inference. We don't need to check it. We could infer from that. If the degree of the curve is 4 and we already have 4 asymptotes, so there is no scope to get the asymptote more than 4, that is the degree of the curve. So this will have no oblique asymptote. We can infer from here no oblique asymptote. So this was the general working rule to find the parallel asymptote of the algebraic equation. Next, find the asymptote of the curve given by a square x square minus b square y square is equal to 1. Take the LCM. A square y square b square x square divided by x square y square is equal to 1. This implies that a square y square b square x square is equal to x square y square. This implies that a square y square minus b square x square minus x square y square is equal to 0. Now to find parallel asymptote parallel to x-axis, the equation number 2 can be written as highest degree in x is this one and this one. So we can write this as a square y square minus y square plus b square x square is equal to 0. Now coefficient of highest degree in x is equal to y square plus b square. So we shall equate this coefficient to 0 to find the asymptote parallel to x-axis. This implies that y is equal to plus minus b iota, which is imaginary value, Therefore, given curve has no asymptote parallel to x-axis. Next, we shall see asymptote parallel to y-axis. In this case, we write the equation number 2 as collect this club to y, highest degree in y, highest degree in y. The equation number 2 can be written as a square minus x square y square minus b square x square is equal to 0. That is asymptote parallel to y-axis. Then coefficient of highest degree in y is this one, equated to 0. So this implies that x is equal to plus minus a. So these are the asymptote parallel to y-axis and are called vertical. These are called vertical asymptotes. So that is how vertical and horizontal asymptotes, that is parallel asymptotes, are calculated. In the next video, we will see how to find the oblique asymptotes, that is how to find oblique asymptotes. To be continued in next video, which will be very soon with you. And so today we have studied the definition of asymptotes and learn the method how to find the parallel asymptotes. So, and we also classify the asymptote in parallel asymptote as well as in oblique asymptote, and also learn the method to find the parallel asymptotes. In the next video, we will just demonstrate the working rules to find the oblique asymptotes of the given curve. So this will be in the next video. So this was all from my side, and if you have liked the video, then please do share, comment and like. If you have really enjoyed watching, like the video and share among your knowns and other students, so that the maximum student could be benefited with this video, as I believe and I really feel that knowledge shall be available to all and it must be free. So if you really feel that this video is worth watching for graduation student and it must be shared to your loved one, so please don't wait and share it to your loved one so that they could be benefited, and ask them to subscribe my channel so that this e-learning program could reach to every needy student of the society. That's all from my side. Your comments in the comment section as feedback are valued and welcomed. So thanks for watching, and that's all from my side. This is Dr. Rajesh. Thanks to all. Thanks.